Alright, so this is a demonstration of how when you take a current transformer that's properly wound and place it in an electric field, the current transformer can be made to create useful electricity. So this is my current transformer. We're wound in the green magnet wire here. Each end of the magnet wire is wired to this outlet. The outlet has a socket in it that I'll screw my light bulb in it to light it. Primary circuit that's creating the electric field around the current transformer is here. It's a power cord, and I have it split into two legs. And one leg is wrapped around this side of the current transformer, comes out here, and is wired to this outlet. The other leg comes over here, the white wire, and it's wrapped around the current transformer, comes out here, is wired to this side of this outlet. This outlet currently has, tested here, 121.4 volts. There's no amps being pulled through it because I don't have anything plugged into it. Now, I take this heater cord and plug it into this outlet. You can hear the current transformer start to hum. And I have 10.8 amps being pulled through the primary circuit. Now, I wouldn't normally pull so many amps through the primary circuit, but since I'm trying to demonstrate just the lighting of a bulb, I'm pulling a large amount of amps through it. Normally I would only wire this current transformer up so that it needed a half or maybe 1 amp. And then you have several current transformers all stacked up in order to produce efficient, useful power. But for the sake of this demonstration, I've amped up the amps so that they're higher and there's more wattage going through the primary circuit to demonstrate what I'm trying to demonstrate here. So at 10.7 amps being drawn through the primary circuit, see how many volts we have now at the outlet in the middle of my current transformer here. We have 150.1 volts at the outlet. So if I take this bulb and screw it into this socket here, you're going to notice 3 things. 1, the light bulb will light. 2, the current transformer will stop buzzing like it is. And the amps are going to do something interesting here. I'm currently got 10.9 amps. And if I screw this bulb in, you'll see the amps drop to 10.1 to 10.2. Fluctuating right in there. So it's an interesting aspect of this, that when I plug my light bulb in here, the amps all of a sudden drop in my primary circuit. Don't know exactly why. That's actually a good thing. So there you go. Alright, so this is my current transformer winding station here. I've got this little jig built and I just wanted to walk you through it a little quickly so you can see how I do it. This is a piece of plywood 3/4 inch that I have C-clamped to my tabletop here so it doesn't move. And I've got this U-shaped section cut out of it here. And that's so that when I set my current transformer, my cord down here to wind it, I've already started winding this one, as you see. It allows me to pass my spool of wire through the middle of it here. And you can see that I have a block of wood on each side here to keep the transformer from falling off the plywood. And then I've got a block of wood back here. You can see how it's stepped so that as the current transformer gets thicker, I just pull it out and it continues to hold it in place so it doesn't flop around anywhere. It just kind of holds it in place. And then I'll wind it here a little bit for you so you can see how I do it. I just take my spool of wire here, which has a few hundred feet of magnet wire on it, and then I just go to town and I wind away, and it goes pretty quick. And let's see, I've been doing this a little bit, so it doesn't take much time to wind these once you get rolling. And you just count as you're doing it, and then keep a little tally every time I count to 100. I just keep a tally so I keep track of how many times I've wound this. This has right now 4,000 windings on it, and it really doesn't take as long as you might think to do that once you get rolling. So anyway, I just wanted to show you what I have set up here, so that makes it easier for you to build your own. Thanks. Okay, well, this is an example of a ferrite toroid and what it looks like. And this is really too small to be workable because they're really hard to wind when they're this small. I really recommend getting something larger like this. This is about 7 inches in diameter, and this is much easier to work with. You get much more power and just a lot more workability to it. This is an example of a smaller current transformer I wound when I was doing some experiments, and you know, it can work. It did produce power. You'd need quite a few more of these wound together or wired together in order to produce a decent amount of power. This is a current transformer I bought on eBay. It was pre-wound and dipped in epoxy, and really, you know, I thought it might be an easy way to do it, but this hasn't really been tuned properly, and so I don't recommend just buying pre-wound ones. This is a little jig I built here, and to wind smaller current transformers, I just have a clamp in the top of it here, and I just clamp the current transformer there, and then I can wind it. I made this device here to thread the magnet wire on, and we put it in the center of the current transformer here, and we can wind this with wire and then wind the wire onto the current transformer. And I just made this out of a piece of PVC pipe that I put in the oven, and got it soft and bent it in a circle, and then cut a slit into it so that I could wrap a lot of wire around it. And just saves me from